Today I'm basically I'll walk you through one of our project which we did some time back. This deals with material flow and also simulation. As you know, according to Lean, any material handling is a non-value added work, but unfortunately, no, we cannot eliminate the material handling, but we can reduce the impact. So I think this is one of the case studies where I'll walk you through what we did, what was the objective, how we went about looking at the project, and also reducing some of the non-value added time or indirect labor. So going to the overview of the project, this was performed in one of the stamping plants in the automotive industry, and they wanted to kind of for us to come there, take a look at their indirect labor and recommend some of the changes in terms of the number of indirect labor required, how the material was flowing to the stamping presses, and they wanted to see what can be done to reduce the flow or what to say, reduce the non-value added part of the material handling. So again, the overview was basically to reduce your indirect labor and also improve the material flow, and also look at various labor assignments, which include forklift, truck drivers, stock chasers, people working in the warehouse, etc. Again, overview. This project given to us, again, we had to go there, take a look at perform all the IE studies, look at all the warehouse, how the material were flowing from the warehouse to any intermediate market storage, and from there how it was flowing to the line. And also we're looking at all the flow rates, your production operational parameters, your takt time, your shift times, and basically your personal work times. So, and also basically look at the simulation, the planning and operation simulation tools were developed by PMC to study the various indirect resources. As I mentioned, tools were usable by trained plant personnel to run some what-if scenarios. I mean, that's the beauty of simulation, right? When you create a simulation, you do replicate your existing process flow, and once you have that current state model, then you can start playing with things around, doing some what-if scenarios. Again, some of the static models or static material flow model interfaced with the AutoCAD layout. I'll walk you through some of the static analysis which we did. So as you can see, this is a kind of a high-level view of what we were trying to achieve there and how we went about doing it. So basically, we had to look at your a plan for operation. That's where you had all the non-value added activities happening. So we had to do some IE studies, collect some times. There might be your loading time, unloading time, what other issues, or other times we had to collect. So once we had the IE studies done, then we basically fed that into a static model. That's basically a static material flow model, and to see how the material was flowing inside the plant. So once we had that material static model, then we fed that data into a dynamic model to get fine-tune some of the things which the static model basically recommended or showed some constraints in the flow. So again, some of the inputs going into both the static and the dynamic model was of course your IE data. You needed the plant layout, material flow data, and also your production schedule. From there, the data, again, the results from these two models were graphically presented to the client, and also made some recommendation. And also we worked on some IE systems where we basically helped us to improve the material flow, or basically replenishment times to the line. Again, I mean, summarizing some of the project benefits, we were able to relocate 21 the personnel there, 21, and also on an immediate basis. And there were 14 work assignments that will be relocated with the implementation of infrastructure improvement. And also the 24 work assignment could be relocated with union consent. So again, this was a union environment, so we had to take into account the union consent before we reallocated any indirect labor. And overall, with this project, we kind of saved 4.15 million in addition to the equipment and also the maintenance cost. So I'll basically walk you through some IE studies we did. Again, as I said, for any study, any study we like, especially IE studies, the first thing is data. So we need data about what's happening, your process flow, your times you're taking to load, to pick something from the warehouse, dropping it off at the work centers, and all or any associated handling times. So we went there, did some MODAPs, did some time studies, and collected a lot of data, because there were a lot of close to 45 indirect labor, and we had to collect some each circle of work compressed of something different. Now some people were cutting the bands over the pallets, removing the shrink wrap. So those some of the times we collected, and those were standardized so that could be used for any studies going forward. So there you can see some of the IE studies captured actual indirect labor move patterns. That means you're showing how some of the indirect labor were moving inside the plant. You were kind of they were moving more in the diagonal, but again you can see the distance that they were traveling. And the chart on the right-hand side basically shows the utilization of some of the resources over time. And as you can see, during the 7th or the 8th shift, you could see a drop in utilization there. So that might be because of what you can say, they didn't have that much of work during the last hour, but because if they already supplied the material or delivered the material to the line, and they were kind of getting ready for the shift to end. So these are things, when you plot something over a period of time, you need to see how might be utilization of labor, but might be utilization of equipment, or any other things. As you plot against time, that gives you a good idea about what's happening. And basically, we need to investigate, what can be done there, either to improve or eliminate that. Again, as I said, we collected data and looked at several indirect material handling personnel there. And you can see some of the utilization of some of the resources are pretty low. You had a crane operator who was kind of used close to 30%. You had other material handler who was working in the main dock, who was kind of used only 23% of the time. So we kind of had to look into all these personnel, look at the utilization, and see what can be done to reallocate or combine some personnel and kind of reallocate some of the work assignments. So basically, I'll get into some static and dynamic simulation which we did. Now, as I said, once we add all the IE data or some of the time studies data collected, we basically fed that into a static model. So in a static model, we were looking at these are some of the data which is basically available in the PFAB. That's basically planned for every part. This is very important for static analysis or dynamic analysis. You need the part numbers, your production quantities, your schedule, part routings, usage, containers, containers per trip, container density. Of course, you had a load and unload times which we had collected, and also location of your storage. So where exactly is your warehouse, or you might have an intermediate marketplace somewhere between your storage and your assembly. Sometimes it might be very close to your assembly too. In the static model, for this, we basically use a flow path calculator, which sits over AutoCAD. That means it's like kind of more of a plugin, but it's a very good tool to get an idea about how things have been moving around the plant. And I'll show you in a couple of minutes. You can either have to do a Euclidean flow, that's basically a straight line flow, to see how from where to where in the facility the parts are moving, and you can make it flow through the aisles. To see again which of your aisles might be congested, and also you might force certain movements to go to a different aisle based on the congestion there. And also this again, it's a very good tool to again perform what if scenarios And if you have a specific route being highly utilized, then you can kind of allocate some of those work content to a different route and see what's going to happen. Again, it's very graphical, so it's very what do you say? It gives you a good understanding of the flow, and also especially to present this to your upper manager, upper management. It's also kind of it's very graphical for them to look at it. So this is the material flow being done using the static, or say the flow path calculator. So you can see, again, this is a Euclidean flow. That means it's a straight line from the source to destination. The flow is not going through any of the aisles. So you can see all the flow happening in the plant. So you can see some of the warehouses which were there. I think you had a starting point here, some of the places there, and you also had some originating from this location here. So this gives an idea about how it's scattered around the facility. Now, is it one corner of the plant, or or in one part of the plant, or it's basically scattered all over? In this case, I would say it's been scattered, but there were two major areas where they were flowing. So this was on your left-hand side and one on your right-hand side. So again, next is basically using the aisle to make it to make the material flow through the aisle. So this way you can see where your most congested aisles are. As you can see, those highlighted basically in red showed those were the aisles where you had high material flow activity. That means it might be your tuggers, your AGV system, your forks flowing through those aisles. So again, it gives a very good representation of a congestion happening in your facility. Again, this is looking at your material flow, and also looking at your utilization. As you can see, before and after, even though there were 4 in this scenario, we had basically 4 operators working in the same geographical area. So you can see the utilization for them here. One of them was highly utilized, 85.44, and other driver B and C were kind of halfway through the halfway mark. So we said, okay, what can be done here? I mean, we know one of them is pretty highly utilized, and other 3 are kind of halfway. So what we did was we looked at their circle of work, or what you can say, your work, your task there, and said, okay, can we reallocate or kind of balance out certain things? So basically, we went about looking at the area and said, all right, we can combine some of the tasks. Like these two was kind of combined there, and said that okay, that the B operator there can take care of that. So his utilization bumped up to 90%, and when we with the relocation of the work, driver C and driver D utilization went higher, and basically we could eliminate driver A from the equation. So sometimes it's we need to just take a look at it, look at the work contents. I think in this case it helped because all those 4 operators were basically in the same geographical area. So that basically helped us. Sometimes even though you have 2 drivers lowly utilized, but they're in the 2 extreme sides of the plant, it becomes very difficult to combine them or basically do any kind of analysis. So once we had the static analysis, we took, almost for the dynamic model, the data requirements are very much similar. You exactly need the same thing what you use in a dynamic simulation, but I think in dynamic simulation, we have more randomness in terms of data, in terms of take rates, or in terms of what it's flowing, or what the assembly line is doing, so that will give a good idea about what's happening over a period of shift. Static model basically gives a snapshot of what's happening, but dynamic model gives you more insight into what's happening over a period of the day or period of a shift. So as I said, the dynamic model gives you a snapshot of not a snapshot, but to see it gives you what's happening over a period of time. So as you can see in one of those lines, you have some high utilization of those operators happening during certain period of the time, and there were some peaks and troughs happening, and so you had some peaks happening almost close to the end of the shift, and there were also no troughs between the shifts there. So we said, okay, what's happening here? Now, what can be done here to help this eliminate this peaks and troughs? So we said, all right. So we were looking at different lines, and interestingly, the peaks of one line coincided with the troughs of the other line. So they said, oh, well, that's good enough. I mean, we can combine some of those peaks and troughs and see how the utilization will work out. So in this line, you can see some of the peaks. We could side with some of the troughs there, and we said, can we combine some of these to kind of have a more, say, uniform utilization? But there were still some peaks happening, but we could combine one operator from one line with 4 operators with one line, and basically eliminate one operator there. So from 5 operators, we came down to 4, thereby eliminating one operator there. So as I said, sometimes the dynamic simulation gives you some good insights about what's happening over a period of time. So I guess with this, it kind of helped us to emulate one of the material handler catering to 2 lines. So I think next one, basically, I'll walk you through some of the forklift and Tugger ID system. I think it was more to do with the IT part of the system. So again, the existing facility didn't have any tracking mechanism to see where the forklifts were moving, how they were utilized. So we came up with a proposal there to have some kind of a system where they could monitor or collect data about how much part of the time you're traveling, how much part of the time you're picking something, loading, unloading, and also how much part of the time you're basically idle. So we had some sensors there put into the forklifts or PIVs, and also basically kind of an asset tracking we had to see what other things can be done, where exactly are my forklifts going, where are they, to see the impact of the battery, could given a kind of notification if the batteries were going low. So some kind of a tracking mechanism we kind of had put in place for the plant personnel to kind of track their PIVs. Again, as I said, so these mechanisms were used to track to see the travel time, your idle time, basically your loading and unloading time at your warehouse or at the station. And also basically, give an idea about at a given point of time, how many of your vehicles were kind of being used. So if you look at this chart here, so these were the total quantity of different vehicles used in that period. But over a period of time, you can see, as the time goes, how your vehicles were being utilized. Basically, that means simultaneously how many vehicles were utilized. Some because of different take rates in the line, different assets, different circle of work. You might not be using all these vehicles at the same time, so there'll be a good opportunity to say, hey, what can be done again to combine some of those vehicles. Sometimes it can be, as I said, if the vehicles are going to the same or working in the same geographical area, then there's a possibility you could combine those work content, and sometimes you have to redistribute also. Again, the tracking mechanism also showed the percentage of vehicle motion during the time, what percent of the time they were moving, what percentage of the time they were idle. So again, it gives an idea about how they were utilized. Again, this was something which we developed so that those to look at their repair logs also. So it's something which we developed from PMC, kind of a database for each equipment. If there were any kind of a repair done, they could log it in, and if there were any preventive maintenance to be done, this could give an idea about when certain things were supposed to do, and they could follow up with that. Again, as I said, the results were basically we reallocated close to 59 material handling, and we eliminated few of them, and basically giving a savings of 4.15 million. And we also had some IT work done so that over a period of time they could track their PIVs in the facility, exactly where they were moving and how they were moving, where they were supposed to go. And sometimes you have forklifts supposed to go from warehouse to the assembly portion. But in this tracking mechanism, you could see whether they were following the right path, or whether they were using a different path, or going somewhere else. So that could give the managers a good idea about how to track their PIVs. And as I said, sometimes the improvements are very obvious, but sometimes you guys kind of have to dig deeper and keep asking questions. What's happening here? Why it's happening here? Okay, can something be combined, reallocated, or basically eliminated? So that's the beauty of lean. Keep asking questions until you can figure out something to improve things around. So in this project, we had to we used kind of three important aspects. One is the data collection. So that's very, very key for any project. We need to know exactly what's happening, and basically some of the data required to perform either your static analysis or dynamic analysis. So again, the static analysis basically gives you a snapshot of the activity, whereas the dynamic analysis gives you it also gives you interaction between various elements in the facility, and also you can track over a period of time how the utilization fluctuates over a period of time. Again, this can be used to eliminate or reduce or rebalance some of the work content. I hope you guys learned something. I think the key aspect, key takeaways from this presentation is spend a lot of time in collecting data. That's very key. Again, garbage in, garbage out. If you don't have good data, you basically will not have good results. Again, try to build one of your current state models so that you can get a buy-in, or get your buy-in from your management, and saying that if this model which shows your current state basically accurately replicates what's happening on the floor. So once they have that confidence, then you can start doing some improvement things. So that way it'll be easier to sell to your management.